So hello everybody, this is a second video about example 2 for phi of n, where here n will be equal to 15, and actually, to make things easier, 15 is 3 times 5. So what is the value of phi of 15? So it's the number of elements which have an inverse in z over 15z, ranging from 0 bar to 14 bar. So let's have this list, expanded so that we can have a quick and convenient way of listing the elements of z over 15z which have an inverse. So just as for the previous example, let's make the complete list. So that's where perhaps we begin to understand that this method is convenient for an example, but not suitable if n becomes greater. And actually, here I will just draw little marks in red if an element has no inverse, and in green if it has. So what we know is 0 bar, no inverse, 1 bar, always an inverse, 14 bar, always an inverse. And actually, for all the others, we will use the fact that 15 is equal to 3 times 5, so that the GCD of A and N may be 1, or maybe 3, or maybe 5. Actually, having the decomposition of n is equal to 3 times 5, let us know that actually all the multiples of 3 will have a GCD with 15, which is different from 1. So those elements will have no inverse. So we can actually drop them from the list. So 3 bar has no inverse. Same thing for 6 bar, 9 bar, 12 bar. On the other hand, the same thing is also true for 5. So if an element or number is a multiple of 5, then the GCD of this number with 15 will be different from 1. So we can also get rid of the multiples of 5, that is 5 bar and 10 bar. So actually, instead of listing elements we do have an inverse, we get rid of the one who don't have an inverse. So all the others have an element. So phi of 15 actually is the number of little green ticks in the list just above. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8. Phi of 15 is equal to 8. So you will have other examples as exercises in the lecture course, and the next video will be video about efficient computation of phi of n. So not that efficient, but much more efficient than trying to list all the elements one by one and computing their GCD.